Alright, this is day 54 of AP Calculus with Sparks, and we're going to talk about the average value of a function. So recall, we found the average velocity by taking the position and finding the rate of change between 2 points, A and B, which is the same thing. Doesn't matter which one goes first. As long as you do P of A minus P of B, you subtract A minus B on the bottom, and vice versa. And then also for average acceleration, this is equal to the rate of change of the velocity. So V of A minus V of B over A minus B, or V of B minus V of A over B minus A. And then off to the side here, I'm also going to write what integral means. So the integral from A to B of, let's say, acceleration, that is going to be the antiderivative of acceleration, which is velocity, evaluated at B and A. So V of B minus V of A, we do the same thing, taking the antiderivative of, the integral of velocity, which is the antiderivative of it evaluated at 2 points. That's going to be P of B minus P of A. So with those two things written down, let's see if you can do P of T, V of T, and A of T representing velocity, position, acceleration. See if you can write equivalent expressions for this and this in this row or column right here. So pause this now and see if you can do it without me. Alright, so by substituting in what this is equal to, taking the antiderivative of acceleration, we get the velocity at B minus V of B minus V of A. When we multiply that together, we get this, which we'll notice this is equal to, whoopsie daisies, this is equal to the average acceleration. Same thing down here, this is equal to the average velocity. So now we can define the average value of a function. So now we can define the average value of a function. It's going to be 1 over B minus A times the integral from A to B of the function f of x dx. So let's try it. Find the average value of the function. This does say calculator because we do not know how to take the antiderivative of this mess. So the integral from 1 to 3, so we have 1 over 3 minus 1 times the integral from 1 to 3 of x cubed square root of sine squared x dx. Well, in the calculator, this is going to be 1/2 of whatever that integral is. You put it in your calculator. And I got, excuse me, I got this to be equal to 11.696, and 1/2 of that is equal to 5.848. Now the next one, without a calculator, we have to find the antiderivative. So we're going to set up the same way. So we're going to have 1 over 6 minus 2 times the integral from t to 6 of 2 minus 4x dx. So we get 1/4 times the antiderivative of this, which is 2x minus 4x squared divided by 2. We have to evaluate that at 6 and 2. Which is equal to 1/4 2x minus 2x squared evaluated at 6 and 2. 1/4 2 times 6. I'll let you work out the math. I just don't want to make this video extra long, but you should come out with negative 14. On the next page, we have another example, a word problem, and it's right up our alley. A ski resort uses a snow machine to control the snow level on a ski slope, which is true. Over a 24-hour period, the volume of snow added to the slope per hour is modeled by the equation S of t, and the rate at which the snow is melting is modeled by the equation m of t. Both of these are in cubic yards per hour, and T is measured in hours from 0 to 24. At T equals 0, the slope holds 50 cubic yards. So the first part, we're asked to find the total volume of snow added to the mountain in the first 6-hour period. So we know the volume of snow at any time t, but we want the accumulation of that, so we're going to take the integral from 0 to 6 of s of t dt, and we're going to put that in our calculator because that's another messy one we don't know how to do without yet. And 142.413 cubic yards is what you should get. Then we want to find the value of the integral from 0 to 6 of m of t, and also 1/6 of that same thing. And we want to discuss what this represents in context of the problem. So this will be very similar to the one we just did, from 0 to 6, m of dt dt. Up here, this was the amount added. This is going to be amount melted. And we put that in our calculator, we get 81.823 cubic yards. Then, if we take 1/6 of that, it's going to be 1/6 of 81.823 cubic yards. We get 13.637, and this is in cubic yards per hour. Now, why is it that? Why was this one in cubic yards and this one in cubic yards per hour? That would be because we divided by 6 hours, so we changed it into a rate. So that is the average amount of snow per hour in cubic yards that was melting. Is the volume of snow increasing or decreasing at t equals 4? Well, we need to know how much snow there is. So, let's see. Say the amount of snow at any given time. We started with 50, and then we're going to add to it s of d dt, and we're going to subtract out m of t dt. And since we're looking for a rate, increasing or decreasing, we're going to take the derivative of the amount of snow at any given time t. Derivative of 50 is 0. The derivative of this is just s of t minus m of t, and that gives us 11.8 at t equals 4. All I did was plug in 4 right here into t. And that's how I got this number, 11.8. We're talking about cubic yards still, the rate of cubic yards. So, since a prime of 4 is greater than 0, remember we're talking about the derivative. If the derivative is greater than 0, then the volume of snow is increasing at t equals 4 hours. So in this one, we want to know the rate. Was the rate increasing or decreasing? And in this one, we're going to want to know the total amount of snow. So we're going to take that function, a of t, subtracting melting, and we want to know what happens at 5. And we put that in our calculator. We end up with a of 5 being equal to 95.335. We're talking about the amount of snow, which is in cubic yards. Alright, part E. Suppose the snow machine is turned off at t equals 10. Write, but do not solve, an equation that could be solved to find the time, or t equals k, when the snow would all be melted. So what we want is we want the amount of snow, which we defined as A of t, to be equal to 0. But we want to know at what time k does that happen. So A of t is equal to 50 plus integral from 0 to 10, because we're only making snow until t equals 10, then we turn it off, and then we subtract out from 0 to 10 mdt, because then we'll know how much snow we have at 10. I guess this is actually 10, not t. When we put this in our calculator, we end up with 183.193 cubic yards. So this is how much snow there is at time t when the snow machine is taken off. So then we would need to say that 183.193, how much we have, and now we're going to subtract out 10 to k mt dt, and we want to know when that is equal to 0. And we don't have to solve it, we just have to set it up. So that is the end of this video, and I will see you next time.